Good afternoon. This is Mohammed Elhenawy. My degree is in computer engineering. I'm a research fellow at the Center for Accident Research and Road Safety, Queensland University of Technology. And my research interest is applying machine learning and statistical learning game theory to improve the road safety. Recently, I'm working in three big projects, and each one of them actually is using machine learning. So let's first introduce what is machine learning. So machine learning is simply is the science of teaching computers to learn from data. And machine learning is mainly three big areas. The first area called unsupervised learning, and supervised learning, and finally something called reinforcement learning. In this placement, we will introduce you to the first two areas, unsupervised learning and supervised learning. So let's quickly know what is unsupervised learning. So unsupervised learning actually is we teach computer how to answer question like what is the natural grouping among these objects you see on the slide. So could anyone answer this question? Do you think how many groups, or how could we group these objects? Okay, so yeah, actually we have many answers. So one of the answers is this: we can group these objects based on the shape. So we can group circles and rectangular in another group, or based on color. So this is simply what is unsupervised learning, is how to group unlabeled objects. I didn't tell you what are the names of each object. So one of the application of this area is grouping a big group of news article into technology, sport, entertainment. There are many other applications, but this is an example of an application. And actually, we will teach you one of the basic algorithms to do or to answer such questions. So the other area we are going to introduce you to it is something called supervised learning. So now we have almost the same data, but we have something new called label. So with each data or each subject or object, we give you a label, a name. And again, if I give you this data to you, and now you know exactly how rectangular, triangle, and circle looks like, and then we need to ask the question, what are these objects? So actually we need the computer to answer this question. We need the computer to recognize triangular, circles, rectangular, although they are have different size, different colors, but we need the computer to recognize the objects. So, and one of the application of this in this area is something called object detection, and it's very basic application for autonomous vehicle. We need the vehicle to use cameras such that it can see. So now, based on the video streaming from the camera, the car or the autonomous vehicle can actually spot every object and give it a label. As you can see, this is a person, this is a car, this is a bicycle, and this is very, very, very important and very critical application for safety. Now, so these are the two areas we are going to introduce to you. And now this is a very examples of how we can use these simple ideas in very complex system like the driverless vehicle. So the first video is almost 30 years old, and the second video is a recent video, and yeah. So in this video, you can see how we can use supervised learning to do a very complex task like steering the wheel, the driving wheel of a car. And in the second video, after 30 years of this pioneer work, now we have something similar to this. Oh, sorry,
Mohammed, I think is some of students asking for the sounds. It's not clear. Hello guys, everyone can hear? Okay, Louise saying no. Some of you saying yes.
So
yes,
we'll share the YouTube link with them. In this placement, we'll give you the very basic ideas of these techniques, and hopefully in the future, you can develop something which can make our roads more safer. So Mahmoud, now the floor is open to you.
Yes, please.
So do you want me to?
Yes, please. Just to move the slides. Yes, please. Hello, everyone. My name is Mahmoud Masoud. I am a researcher at QUT, the Center for Accident Research and Road Safety, QUT. I had PhD in optimization and decision sciences. In this session, I'm working from home, so not from my office, and I hope everyone staying safe. So the research interest mainly mathematical modeling and optimization, and that is what we're gonna highlight in this session. We need to understand how much the mathematics are important, and we have very interesting concept called optimization. So we're gonna touch in this session the two concepts, mathematical modeling and optimization. So we, in mathematical modeling and optimization, the message which a mathematical model and optimization send for everyone saying, focus on being productive and do not on being busy. The most important thing, guys, to be productive. And that is the message of the mathematical modeling and optimization. Optimization as a concept. So you need to make everything is more efficient. If you have like a system, and any system like educational system, health system, any system, you need to improve the quality of the system and how you can make this system is working very efficient. That is most important. So optimization, modifying the system to improve the efficiency. Okay, so you can consider your day. Can you please, Mohammed, just one slide back? One slide back, yes, please. Yes, thank you. So you can consider, you know, your day as a system. So you need to be productive during your day. So you have the time scheduling for this day, for your classes, for your lectures, for anything. You need to organize this system or modify the system to be more efficient, okay? So the outcome of the system gonna be more productive, okay? So the first concept, optimization, or first definition, I would like you to know the optimization modifies system to improve its efficiency. This either reduce the resources, so you need to reduce your resources, but you're getting more increasing in the performance. So you need to improve the performance even you have limited resources. Mathematically, you have function. So that is the second definition. So you have function, and this function processing some ideas based on some inputs, and you are waiting to get outputs or outcomes based on some constraints. So like you need to have like full model. So the model including the inputs, function, and the outcome, which based on some constraints. So second one, I would like to highlight the mathematical modeling. In the next slide, the mathematical modeling. Second slide is the mathematical modeling. Thank you, Mohammed. So what is the meaning of mathematical modeling? Many questions for the specifically high school students asking, what are the main benefits? What are the main benefits of mathematics? How can we use mathematics in the industry, in the real application? So the start point or start stage is you have real life problem. Any problem, maybe industrial problem, maybe educational problem, any problem you can identify saying, yes, I have this problem. So you need to translate, okay, this problem into mathematical equation. So each equation expressing some events or some actions or some items, including in the real life problem. And then once you translated real life problem into mathematical modeling, you can try to solve this model. But take care, because how much you accurate in your translation, how much get very good outcome. So you have to take care about translation between real life problem into mathematics, and then try to find the best way to solve this mathematical model. Okay, and once you solve this mathematical models, it's gonna be like numbers or values. You need to interpret these values, what these values means. So because you have to return again these values into reality. So solution to real life problem to say, yes, that's what I'm looking for. So if I would like to take a decision about, you know, you need to construct, for example, small factory or small business, and you wanted to know how much this business is gonna be efficient or how this business is gonna give you more profits. So you need to identify your business in some equations, like inputs, like, you know, the resources of this business, the limitations of this business, the market around this business, the environment around this business. Once you translate this business into mathematics, solve the mathematics, then get how much benefits you have got from this business. But based on the mathematical model and the optimization, in this session, I'm gonna show you how many applications. We have lots of applications can use mathematical modeling and optimization. So in the next slide, I would like to highlight, real applications for optimization and the mathematical model. First application is cooperative and highly automated driving. So now the very hot topic in transportation, specifically in intelligent transportation, the automated vehicle. So the development of automated vehicle, you need to make your automated vehicle, which driveless, understanding exactly the reactions of human being, the reaction of the environment. How can your sensors in the automated vehicle, react to the environment? So mathematical modeling and optimization try to get the algorithms, the procedures, which gonna need to translate the actions of the environment around the automated vehicle into some understandable things to the automated vehicle. Okay, and so next one, I can use the optimization and mathematical model in health sector. So if you'd like to optimize the system inside hospital, you need to optimizing the performance inside this system. So you need to transfer your system into mathematical modeling, mathematical equations, and use this model to try to get better system, more efficient. So currently we're working on the system, mathematical system, to get more benefits inside the emergency department as a project. And we try to integrate multi-medical units inside the hospital to make the system inside the hospital more efficient. Based on limited resources, based already we have high demand because we have lots of customers need to be served inside the hospital. But we have limited time, we have limited resources based on the doctors, based on nursing, based on the equipment itself. So we need to optimize. How can we optimize, make the system more efficient and serve many customers in a proper way? Next slide. One of the project which already I worked on, Australian digital beef supply chain optimization. So Australia is very competitive country in producing beef. So the problem is we have like international contracts with other countries. Okay, we need, of course, as an Australian government, satisfy these contracts. But the problem is we cannot predict exactly, for example, next year, how much how many cattle we have, because we have, for example, the number of cattle based on farming. So if we have some natural crisis, so the farm is gonna be affected, of course, negatively, and then we need to highlight, or need to get very predicted and efficient system to give us very correct numbers about your expectation. So of course, mathematical modeling and optimization, one of the very important tools. Next slide. Last slide, the Australian biomass and the bioenergy assessment. So this one of the projects working on bioenergy assessment. So Australia, because we have biomass, so the many factors working on the bioenergy, because we need to save energy, we need to, so mathematical modeling and optimization, we need to identify exactly, which areas around Australia, inside Queensland, is better to construct bioenergy factories. So this is gonna be used mathematical modeling as well. I think I have like one more slide, that is last slide. And sugarcane, Australia as well is very competitive in sugar. How can you optimize the transportation, freight transportation in many systems? To model this system, you need to have very good background in mathematics. You need to know exactly the algorithms and the tools in optimization to make the system efficient in sugarcane. Specifically for railway system, you try to send your products and waiting to from the drivers to bring the cane from different area around Australia. You need to make the system more efficient, working in very good way, reducing, of course, costs, make everyone happy, even the customers or the owners of the sugar factory. Yep, thank you very much. That is very quick slides about using artificial intelligence and the mathematical modeling in very real industrial application. So we are very open to receive any questions, guys. Excellent. Jeremy saying, how long does a model take to produce? That is very, very interesting, Jeremy, question. Thank you very much. To produce the model, how long it takes based on how much understanding for this model, how much you understand the real problem. Jeremy, if someone telling you about a problem, so when you understand correctly the problem, you can give him the very suitable solution. Same, when you try to transfer any real problem into mathematical model, first of all, I need to understand the real problem. Second one, I need to understand what is the target of the problem, what type of solution I need to give the customer. Once you understand those things, I start with the tools, mathematical tools, which I'm gonna use to produce my model. For example, I'm gonna use linear programming or mixed integer programming or nonlinear programming. Which mathematical tools I need to use, of course, based on your understanding for the problem. And how long it take, of course, based on your ability, you know what I mean, to deal with the real problem. Excellent.
Mahmoud, there is another question about what precaution do you take to ensure the system isn't fragile? For instance, how do you account for unexpected variables such as unexpected demand?
Yes, that is another very interesting question regarding to, for example, if we don't have no crops or unpredictable demand. So this based on very important thing. We have history regarding to your problem. So history records, we have like historical records. So it's saying, okay, last 5 years, like last 10 years, our expectation or our outcomes based on the contracts. For example, okay, I'm expecting next year to produce 100,000 cattle, okay? But for any natural crisis, this didn't happen. So how the mathematical modeling, you know, expect something based on these things. So the mathematical modeling using something is called stochastic variables. Stochastic variables means not deterministic variables in your model. This means these variables, it's not deterministic, it's gonna be predictable variables based on some situations. So the crisis, the nature of the crisis, minimum or maximum, it's gonna be very big or very low based on, of course, your experience in last, for example, 10 years or 50 years. For example, in Australia, recently there was like flood. And of course, the whole Australia has been affected negatively based on the flood. So of course, based on last 50 years, we expecting the rates of the flood, okay? Based on the environmental factors, based on the, you know, many information we have. So based on these factors, we're gonna consider in your model to expect, you know, upcoming crisis in your real application. I hope that it's clear because that is very important question.
So there is another question about the scripting language we are using. We in this course we will use MATLAB, but if anybody of you has a previous knowledge in machine learning, one of the most used languages because it's open source, Python. We also use Python, but in this course again we are going to use only MATLAB. Mahmoud is using a special tool for optimization.
I look Simplex, yes.
Yeah. Another question. It's about
when you were, yes, shape
okay.
Shape identification, yes.
So my understanding is that you are asking what if a mistake happened while a car trying to identify an object. So usually autonomous vehicle doesn't depend on only one sensor. By sensor, I mean, so camera actually is one of the sensors. So autonomous car has different sensors, including cameras, and it make its decision based on diffusing the input of these different sensors. Still, there is a problem, and we know there is a problem. And right now, one of the research topics we are working on is analyzing something called disengagement of autonomous vehicle.
Yes.
And we know there is a problem. And this is why there is this topic of research is very active. And we are trying to come up with new algorithms, new techniques, which is very, very accurate. And have a very, let's say, a very small probability of false positive. We will expose to these terms in the placement. False positive, true positive, false negative. So we will introduce you to these measurement criteria or performance evaluation criteria.
Just to Mohammed, please, I wanted to, for Nick, I wanted to add very quick input in this question, because that is, as Mohammed mentioned, under something is called data fusion. So yes, we getting the data from different sensors. You know, sometimes there is like differences in the output of the identification for each sensor. So data fusion tried to make, you know, the all sensors working on identify the object similar, you know, but as Mohammed said, it's a big job, it's a big challenge. So it's still researchers working in this stuff to avoid, of course, accident or crashes.
Yeah. So another question about testing. Yes, of course. In general, in machine learning, while we are developing any model, we use data for training and something called validation, and then there is completely different data. I mean, we didn't use it during training or validation. We keep it away until we develop the model, and then we test the model with this data. In the case of EV, it is quite complicated because it's so in order to build a good model, you need to have a data, we call it a representative of the population, which means that it has a sample of every single possible scenario could happen. And this is not the case in EV. We don't have, there are very, very rare scenarios. We don't have any information about it. We don't have data about it. And if the car face one of these scenarios, it can't do the right or can't make the right choice. And this is another problem. This is why some of the publication, recently publication said that we need 500 years to statistically guarantee that autonomous vehicle will increase the safety of the road user, which is huge. I hope this answers your question.
Yes, Lewis asking as well, there was something about heuristics on one of the slides. My understanding is that is the field, this field, a lot of models are used for in artificial intelligence. Yes, heuristics, it's like type of algorithms, and each heuristic or each algorithm try to solve a specific problem based on the characteristic of this problem, and each heuristic try to identify the items of this problem or item of this situation, or the, you can say, variables of this situation. And once you identify inside the heuristic the situation or the problem, the algorithm try to solve this problem.
Last question, it's ethics. Actually, I was in conference 2 years ago, and one of the attendees raised this question, and on the stage was one of the pioneers in autonomous driving, and his answer was, if the car reach at this point of a choice between killing a driver or other people, then the design is wrong. There is a big problem in the design. So right now, researchers in every research lab, they are trying to find, let's say, solutions and algorithms that guarantee we will never reach a point where we need to make a decision to kill a driver or kill pedestrian or other road user.
Yes, I agree, Mohammed. Thank you. It's a big debate, you know, Nick. It's a very big debate, you know. Still, the researchers working. How can we solve this debate, you know? But it's a very critical question and very critical issue. Yeah, thank you very much for highlighting this one. Yes, Mohammed. If guys, anyone has like any more questions?
So Mahmoud, so actually in this placement, I know maybe mathematical modeling is difficult for some of you because you don't have the required background, mathematical background. So I think Mahmoud is going to give you the very basic required background, and then he will focus on one or two of the heuristics, which is actually very easy to understand.
Yes, I agree. You know, I agree. We're gonna start from the basics, like starting from real problem. So I'm suggesting, you know, we discuss of one of the real problem and starting how can we translate this problem into the mathematical modeling, and then using some tools, solution tools to solve, or heuristics to apply for this problem to be solved.
I think we have one last question from Nick. How do you code a specific situation into a machine so it has a set way to address it?
Could you please repeat it? I
think one thing I have always been wondering, how do you code a specific situation into a machine so it has a set way to address it?
I wish I understood the question, but usually so while we, or before we train a machine learning algorithm, there is a pre-processing step called feature extraction, which means that we don't we don't give the algorithm the raw data as is. For example, in our supervised example, which has the shapes, so we can simply use one feature, saying that if the feature is how many vertex for each figure, and simply the algorithm will learn that if we have 3 vertex, then this is triangle. If it is 4, then it's a rectangle. If infinity vertex or no vertex, it's a circle. So usually there is a mapping step between or pre-processing step between the raw data, which could be images, speech, any kind of data modality, into a representation form called feature space. And then we use this feature space to teach the algorithm or to build our machine learning model.
Okay, thank you guys. Thank you very much for this nice session, and please stay safe, and I hope you're enjoying your sessions. Have a lovely one.
Thank you.